However, there's another interpretation of relativity. And in this regard, I'm going to be talking about a guy called Whitehead, who we could see, let's say, as the Kant of relativity. He's somebody who proposed already in his concept of nature that what we're talking about, in fact, when we're talking about relativity, is not fixing time, but actually keeping the idea of simultaneity. That the idea of simultaneity, as far as time was concerned, is the crucial issue. And he proposed, and this is, both of these pictures are by Escher, by the way, and Escher was obviously a very, very well-read man on these issues because he understood the issue here perfectly. The painting on the right there is called Three Worlds, and what you can see there is the relativity that he's talking about are different ways or different perspectives on looking at the world. So instead of like the world being kind of reduced as in Einsteinian space-time to one thing again, that's what Einstein did. He took relativity, he fixed it back into one thing again. What Whitehead was saying in his concept of nature is actually the world is multiple. So we can have multiple worlds in this one world, dependent on observation. And observation is always an important part of the relativity concept. So dependence on observation, dependence on this idea of simultaneity. Some very recent, you must remember that, like, as I said, these ideas are presuppositional. They're very, very embedded in the way that we think, especially the absolute notions of space are very, very embedded in our presuppositions. A guy called Rob de Sale, or de Sal, I'm not quite sure how you pronounce that, said that in fact what had been done in both creating absolute space and relative space was very, very similar. I mean, what these people had done, and you'll notice as we go on here, that there's a certain kind of change of emphasis, a change of the direction, let's say, of looking at the problem. They'd done similar revisions of work previous to them. And the instrument that they'd used in both cases in order to resolve certain problems of definition in the scientific work that they were doing was geometric. They had used geometry as an instrument to kind of resolve problems of definition. And he said that what they were doing was constructive and geometric rather than theoretical. They weren't dealing with theory so much as they were dealing with trying to link some ideas on the one hand with empirical data on the other hand. And the instrument they used to do this linking, and this linking is done very, very well by the respective geometries, is the geometry itself. The upshot of all of this, the important part of all of this that comes out of de Sal's comment, remember that he is still a person who's deeply embedded in physics, is to say that space-time is not real. Space-time is conceptual. Space-time is an instrument. Space-time is something that we use in order to put things in the world together. In other words, we impose space-time on the world. And space-time is specifically, in these cases, a geometric coordination of ideas and data. Whitehead, as I mentioned before, I'm going to go into Whitehead now, and then I'm going to leave it a little while I talk about more about construction. Whitehead, in his concept of nature, talked about there being no objects, only events. He kind of threw out the Leibnizian idea of object and said we have to look just at relations and how things are put together in relations. So all of these events are discrete, but at the same time they can exist together in relational, what he called societies. Events, in his understanding, in his cosmology, extend across space-time. He's very concerned with relating this to the idea of, or the new ideas of space-time, and the idea of space-time being inseparable. And that this space-time has something to do with these societies that he's talking about. He puts it most clearly in some of his earliest work. The time that he's talking about is simultaneity here. He's talking about at certain moments, certain events come together. He would say, like, for example, in this room here, there's a certain simultaneity. There's a kind of order in this place here, which is relational, and it's held together in time. It's not held together so much in space. The space is the kind of extra issue, if you like, but the crucial issue. What holds us all here is time. The idea that simultaneity for us is all the same thing, in other words. We're all simultaneously here together. We understand what simultaneity means in this context. And he's saying that all of these conditions, this is where the world's idea starts to come in here. All of these conditions are in fact local spaces. Okay, so we have one of them here. Okay, we might have another one which is the whole building, for example, where there's a certain kind of simultaneity, where the time dimension is held together by the fact that all of these things are interrelated and working in some kind of concord, some kind of simultaneity with each other. They're synchronized, if you like, with each other. Whitehead, apart from that, constructed his own Einsteinian relativity, but he used a different geometry. And the point that he was trying to make here, or the idea that came through in all of this, is that Einsteinian relativity does not depend on the type of four-dimensional affine geometry that Einstein proposed. In other words, relativity can be done with any space. And the Einsteinian relativity, including the kind of gravitational issues and so on, can be solved with Euclidean geometry as well as with this four-dimensional geometry. So what he's kind of emphasizing here is, although we are stuck with this kind of relativity notion, that space-time are always interlinked with each other, at the same time space-times are multiple. There is not just one kind of objective space-time. Space-times are multiple and constructive. From here, I mean, the notion of construction, I take the argument on into the notion of construction. Start talking about theories and objects, co-constructed. This is Nancy Cartwright. I don't know how many of you have heard of her. She's one of the most preeminent philosophers of science since probably the 1970s, and still working today. She says theories and objects are co-constructed in controlled situations. And you start seeing here, coming out of here, and this is the theme I'm trying to develop, this idea of construction. It's rather moving away from ideas of there being sort of theory, which are a kind of abstraction of the world, or that theory should be real in the sense that they somehow represent the world in some way, to this idea always of cobbling things together, of constructing situations. She says theories and objects are co-constructed in very controlled situations, and she's very interested in experimental science. And she calls these controlled situations nomological machines. Scientific lawfulness closed, there are no closed systems. There's a kind of complexity aspect to it as well. She's saying here that the idea of a scientific law is actually one which is closed, that kind of closes the world. Such a thing is not possible in a complex world. In other words, in a world where we accept the propositions, let's say, of complexity science. So there are no closed systems in the real world. That means there are no closed scientific systems in the real world either. And we need intervention and control to shield a nomological machine. So these nomological machines, these things, these experimental situations that we put together to make certain effects need to be really tightly controlled. They need to be shielded from contamination, from extraneous effects, for example, in order for us to get the kinds of things that we call laws, in the world. She actually doesn't claim that laws don't exist. She says that laws are constructed along with the kinds of objects that we deal with in science, and perhaps some of the objects that we deal with beyond science as well. So intervention and control are required to shield nomological machines to